When Eleanor's daughter finally brought these observations to a doctor, it changed everything for her mother. Rather than dismissing the changes as normal aging, her healthcare team initiated a proper evaluation. They identified several manageable factors, including a subtle medication interaction that was quietly impairing her balance, prescribed a safe, targeted exercise program, and established a clear baseline so that any future changes could be caught right at 10 steps in a straight line, placing the heel of one foot directly against the toes of the other, with your arms resting naturally at your sides. It sounds like a remarkably simple movement, almost trivial. Yet, taking that short walk down a hallway in your own home can reveal subtle changes in your brain that standard clinical memory tests might completely miss for years, long before someone forgets a familiar name, long before they misplace their keys or lose their train of thought during a conversation. The human brain often signals that something is wrong in a place where almost nobody thinks to look. It signals that trouble in your feet, in the way you move across a room. A comprehensive review published in the Handbook of Clinical Neurology laid this principle out clearly. As cognitive function begins to decline, a person's walking speed often drops, and their step-to-step rhythm becomes noticeably less steady. These changes in how someone walks can predict mild cognitive impairment and dementia long before traditional memory symptoms ever show up. Not at the same time, and not afterward, but before. That is a concept that truly deserves a moment to sink in. The primary screening method that most people rely on as they age, such as a short memory quiz during an annual doctor's visit, captures a snapshot of a much later chapter in the story of cognitive decline. The way you walk, on the other hand, represents the early chapters. Unfortunately, almost no one over the age of 60 has ever been encouraged to pay attention to these early physical signals. In this video, I'm going to walk you through the precise heel-to-toe pattern that neurologists look for during an examination, and I will explain how you can safely observe it in your own home. I'm going to tell you about a specific medical condition recognized in the research literature that pairs a slowing walk with a subtle cognitive concern, dramatically increasing the risk of future dementia. We will also explore a simple walking and talking check that directly engages the front part of your brain. And we will examine 3 distinct changes in a person's gait that each point to a different underlying brain mechanism. Furthermore, I will highlight the single biggest mistake that causes older adults to dismiss these early warnings for years, usually by blaming a perfectly innocent set of knees or hips. Finally, I will explain one critical detail about the heel-to-toe test itself that most people completely misunderstand, a detail that even healthcare professionals sometimes overlook, which is precisely how early signs of trouble slip past families completely unnoticed. Understanding this connection is vital because it gives you one of the very few early warning signs of cognitive health that you can actually observe with your own eyes, right in your living room, without needing specialized medical equipment. My name is Dr. David. On this channel, my entire focus is to review published medical research on aging, mobility, cardiovascular health, and brain function, translating complex clinical data into plain, practical language for adults over 60 who want to catch health changes in their earliest stages. There are no gimmicks here, no extreme claims, and no panic. Just clear, research-backed insights explained so you can take proactive care of your health. Today, the focus is entirely on gait, movement, and the brain, and the research behind this topic is truly remarkable. To understand how this plays out in real life, consider a story about a woman named Eleanor. Eleanor is 74 years old and lives in a comfortable, single-story house she has owned for decades. She represents a very common pattern that researchers see across countless mobility and cognitive studies. A couple of years ago, Eleanor used to walk around her neighborhood every Tuesday and Thursday with her longtime friend Carol. Their usual loop was about 1.25 miles, and they consistently completed it in roughly 22 minutes. If you calculate the math on that pace, Eleanor was moving at about 1.5 meters per second, which is a very healthy, brisk walking speed for a woman in her 70s. However, by the following spring, that exact same neighborhood walk was taking them 27 minutes. Without saying anything out loud, Carol had gradually slowed her own pace just to stay beside her friend. That change represented a speed drop of nearly 20%, bringing Eleanor's pace down significantly. Why does a small change in walking speed matter so much? Back in 2011, a landmark study published in the Journal of the American Medical Association analyzed data from 9 separate long-term studies involving more than 34,000 older adults. The researchers discovered that an individual's natural walking speed predicted overall health and longevity just as accurately as traditional markers like blood pressure or smoking history. Every fraction of a meter per second mattered. In fact, many specialists in geriatric medicine now refer to gait speed as the 6th vital sign, placing it right alongside heart rate, blood pressure, respiratory rate, temperature, and pain. Eleanor had lost a significant amount of her walking speed, yet no one had measured it or pointed it out, simply because nobody views a casual morning walk as a vital health metric. When Eleanor began to notice that she was tiring faster, she assumed her left knee was acting up. She had undergone a total knee replacement several years prior, and blaming an old joint is a very easy, convenient explanation that almost everyone accepts without second thought. But blaming a joint assumes that physical wear and tear slows you down smoothly and evenly across every step. It does not account for what happened next. A few months later, at a family gathering, Eleanor was walking across a smooth floor carrying a small plate. Her daughter watched her move and noticed something troubling that she could not ignore. Eleanor's steps were no longer smooth, or even one step would be slightly longer, while the next step was noticeably shorter. The steady, automatic rhythm of her walk had vanished. Even more telling was what happened when someone called out her name mid-stride. Eleanor did not simply turn her head or slow down while continuing to walk. She stopped moving completely just to speak. Her memory, if tested on paper, was still entirely sharp. She remembered family birthdays, complex recipes, current events, and details from conversations weeks ago. If her doctor had administered a standard short memory test at that time, Eleanor almost certainly would have passed with high marks. Yet her physical walk had altered in three very distinct ways. Her overall speed had decreased, her step pattern had become uneven, and her ability to walk while simultaneously processing speech had deteriorated. Each of those three specific changes aligns directly with what scientific literature describes during the years leading up to measurable cognitive decline. Way. The reason Eleanor's experience is so important is that her situation is not unique. It is typical. The time she spent assuming her knee was the sole culprit is the exact same period that thousands of families lose every year, simply because no one told them that a person's walk is often the very first signal of a changing brain. Why does the way we walk reflect brain function long before a memory test reveals a problem? The answer comes down to how the human brain processes movement as we get older. In short, walking in an older adult is no longer a purely automatic physical act. It relies heavily on the exact same cognitive networks that handle memory, attention, and executive decision-making. Therefore, when those cognitive circuits begin to experience subtle stress or decline, the walk is often the first place where that strain becomes visible. The criteria for Motoric Cognitive Risk Syndrome are surprisingly straightforward. It involves two main factors: a walking speed that is slower than typical for your age and demographic, combined with a self-reported or family-observed cognitive concern, such as noticing that your memory or mental sharpness is not quite as agile as it used to be. Crucially, people with MCR still pass standard memory tests and continue to live completely independent lives. They do not have. When a person is in their 20s, walking is managed almost entirely by lower-level, highly automated neural pathways. The spinal cord and the cerebellum, which sits at the lower back of the brain to handle balance and rhythm, perform the vast majority of the work without requiring conscious thought. Specialized nerve networks in the spinal cord generate a steady stepping rhythm automatically, much like a thermostat maintains a room's temperature in the background. As the brain ages, however, this automatic coordination naturally wanes. Over time, small areas of wear appear in the brain's white matter, which is the wiring responsible for sending signals between different regions. As these connections slow down, the brain adapts by calling on higher-level brain structures for help. Specifically, it relies on the prefrontal cortex, the region located directly behind your forehead that controls planning, focus, complex problem-solving, and decision-making. In simple terms, as we age, the brain reassigns walking from an automatic background task to a high-level task that requires active mental supervision. That active supervision consumes mental energy and focus. This shift is not theoretical. Neuroscientists observe it directly using modern brain imaging technology. Studies using functional near-infrared spectroscopy, which uses non-invasive light sensors to track real-time blood flow and activity in the brain, show that the prefrontal cortex works significantly harder when older adults walk, especially when they are asked to walk and perform a mental task at the same time. Research confirms that even simple activities, like climbing a flight of stairs while focusing on a secondary task, require substantial prefrontal cortex engagement in older individuals. The thinking part of the brain is actively working to keep the body moving smoothly and safely. This concept is supported by decades of clinical observations. Decades ago, researchers began noticing that older adults who routinely stopped walking whenever someone engaged them in a conversation were at a drastically higher risk of experiencing falls in the following months. Their brains were forced to prioritize available mental focus. To speak, they had to pause their feet because both actions were competing for the exact same pool of cognitive energy. When you follow this scientific reasoning to its logical conclusion, the picture becomes very clear. If your physical stride depends on the health of your higher-level thinking circuits, then any underlying process that slowly damages those circuits will show up in your gait, even while your performance on basic memory tests remains completely normal. Clinical research has demonstrated that older adults who experience a slower walking speed or a reduced ability to adjust their steps often show higher levels of key biomarkers associated with cognitive conditions, as well as structural changes in the hippocampus, which is the primary memory center of the brain. The connection between spatial movement and the hippocampus is particularly fascinating. The hippocampus does not just store memories, it also plays a critical role in mapping physical space and organizing sequential movements. As a result, subtle structural changes in this part of the brain can simultaneously affect both the ability to recall a detail and the smooth rhythm of a step. There is also an energy component to consider. Research shows that when cognitively healthy older adults burn an unusually high amount of physical energy just to walk at a standard pace, that extra exertion often correlates with underlying changes in brain structure. Imagine two individuals walking side by side down a street at the exact same speed. On the outside, they look identical, but internally, one person's nervous system is working twice as hard and expending far more cognitive and physical resources just to keep up that pace. Over time, that hidden effort leads to fatigue, causing the person to quietly reduce how much they walk altogether. Now, let us discuss the critical detail about the heel-to-toe test that most people misunderstand. When friends and family members watch an older relative move, they usually focus only on overall speed. While speed certainly matters, researchers emphasize that a second, much quieter signal is often far more revealing: step-to-step variability. Step-to-step variability refers to a walk where individual steps lose their consistent rhythm. One step is long, the next is short, one foot clears the ground easily while the other hesitates. In specialized Gait laboratories, this is measured as stride time variability. In a young, healthy individual, this variation is tiny, usually only a couple of percentage points, because the brain's rhythm-generating circuits are incredibly precise. But as the higher-level neural networks supervising that movement begin to struggle, that step-to-step consistency is the very first thing to break down. A person can often maintain a respectable walking speed for years simply by applying extra effort and concentration, but they cannot easily hide the loss of step-to-step consistency. That is why a test like the tandem or heel-to-toe walk is so valuable. Walking heel-to-toe along a straight line removes all your natural mechanisms for compensation. It eliminates a wide, stable stance, takes away your forward momentum, and forces your coordination, balance, and focus to work without any shortcuts. It lays bare the true efficiency of your nervous system. Recognizing these physical signals led the medical community to establish a specific clinical concept known as Motoric Cognitive Risk Syndrome, frequently abbreviated as MCR. This term was formally introduced by researchers who spent years studying large populations of aging adults. They repeatedly observed a clear pattern. Individuals who exhibited a slower walking speed alongside minor, subjective cognitive complaints were the ones far more likely to develop formal cognitive impairment years down the road. A diagnosis of dementia. They simply possess these two quiet features existing side by side. The syndrome is far more common than most people realize. When researchers pooled data from tens of thousands of older adults across multiple international studies, they discovered that Motoric Cognitive Risk Syndrome affects approximately 1 in every 10 adults over the age of 60. That means in almost any community group, social club, or family gathering, someone likely meets these exact criteria today without ever having heard the term. Medical literature describes MCR as a vital tool for identifying individuals who are at an increased risk of future cognitive decline long before severe symptoms appear, opening up a crucial window for early lifestyle interventions, cardiovascular care, and preventive strategies. Large-scale reviews and meta-analyses confirm that individuals meeting the criteria for MCR face roughly double the risk of developing cognitive impairment later in life compared to those with normal gait and no cognitive concerns. The extraordinary value of this concept lies in its accessibility. Identifying MCR requires no expensive scans, no blood work, and no complex medical machinery. It requires only a simple measurement of walking speed, a safe observation of movement, and an honest conversation about cognitive changes. It is a practical, low-cost screening approach that can be utilized anywhere in the world. To help you see how these early gait changes manifest in everyday life, let us examine 3 different scenarios, as the warning signs can look quite distinct depending on the individual. Consider a man named Frank, who is 68 years old. Frank's raw walking speed is excellent. If you ask him to walk down the driveway, he moves briskly and easily. Frank's primary signal shows up only when he attempts to multitask. Whenever his wife asks him a question while they are walking together, Frank instinctively comes to a complete stop. He plants his feet, answers the question, and only then resumes walking. He jokes that he simply cannot walk and talk at the same time, and those around him usually laugh it off. However, stopping to talk is the everyday version of a failed dual-task gait test. When Frank tries to hold a conversation while walking, his prefrontal cortex experiences cognitive overload. To protect the conversation and process his thoughts, his brain compensates by shutting down the movement of his feet. In healthy individuals, the reduction in walking speed when adding a secondary mental task is very minor. But when a person routinely stops walking altogether to speak, it indicates that the shared cognitive network managing both tasks is running on limited reserves. Next, look at Dolores, who is 79 years old. Dolores moves around her house quickly, so her family never had any reason to worry about her mobility. Her subtle sign appeared during a simple tandem walk test, where she was asked to take 10 steps along a straight line, placing her heel directly against her toe. Tandem walking is a standard part of a neurological exam used to evaluate coordination, balance, and cerebellar function. When Dolores attempted the test, she managed only 3 steps before losing her balance, stepping off the line and extending her arms outward to catch herself. Over several years, her everyday walking style had quietly adapted by adopting a slightly wider stance, a subtle physical compensation that made her look stable during normal walking, but hid an underlying decline in balance. The narrow heel-to-toe line instantly removed that disguise and revealed the true state of her coordination. Finally, consider Raymond, who is 66. Raymond's walking speed appears completely normal, and his steps remain relatively even. His primary warning sign is the physical effort and fatigue associated with walking. A quick trip to the mailbox that used to feel effortless now leaves him feeling drained. Over time, he's unconsciously adjusted his habits, parking as close as possible to store entrances, skipping unnecessary errands, and shortening his daily routines. While family members often attribute this change to simple aging, Raymond's shrinking daily activity radius reflects an increased energy cost of movement. As walking becomes less efficient and requires more conscious mental effort, he naturally avoids it. This creates a challenging cycle. Walking less reduces physical conditioning and neural practice, which in turn causes the underlying pathways supporting movement and balance to weaken further. These individuals illustrate 4 key physical signals to pay attention to: a decline in overall walking speed, a loss of step-to-step rhythm, an inability to walk and talk simultaneously without stopping, and a noticeable loss of balance on a narrow path. Now that you understand the science and the warning signs, let us focus on practical, concrete steps you can take at home to monitor these factors safely and effectively. First, establish a clear walking baseline for yourself or a loved one while everything feels completely fine. Choose a consistent, flat route, such as a long hallway, a level driveway, or a quiet sidewalk. Make sure to conduct your baseline check wearing your standard comfortable walking shoes at a similar time of day, as fatigue and footwear significantly influence gait. If you want a clear measurement, mark out a distance of roughly 13 feet, 4 meters. Time how long it takes to walk that distance at your normal, comfortable pace, and divide the distance by the number of seconds. A speed below 0.8 meters per second is often considered slow in geriatric evaluations. However, the most important takeaway from the research is not a single threshold number, it is tracking meaningful changes in your own pace over time. Recognizing that your usual walk has gradually slowed down over 6 to 12 months provides valuable data that would otherwise remain unnoticed. Second, observe the heel-to-toe pattern safely. Safety must always be your top priority. Never attempt a tandem walk test on a slippery surface in socks, or if you already experience significant unsteadiness or a history of falls. Always perform this check along a sturdy kitchen counter or a hallway wall that you can lightly touch for support, and ensure another adult is present to assist you. Attempt to take 10 slow, deliberate steps in a straight line, placing your front heel directly against the toes of your back foot while keeping your gaze looking straight ahead rather than staring directly down at your feet. Pay attention to 4 key markers: needing to step off the line to maintain balance, reflexively flinging your arms out to keep upright, taking unusually long pauses between individual steps, or exhibiting significant wobble and step-to-step unevenness. Experiencing minor unsteadiness on a tandem test does not automatically indicate a serious medical problem. Inner ear issues, joint stiffness, or simple muscle weakness can certainly make this movement challenging. What matters most is noting a clear shift from what you were easily able to do in the past. Document what you observe, note the date, and keep a record. Third, try a simple dual task check in a safe environment. While walking along a flat, familiar, and obstacle-free path with a partner beside you, attempt a light mental exercise, such as counting backward from 100 by threes or reciting the months of the year in reverse order. The goal is not to test your math skills, but to observe your feet. Notice if your physical pace drops dramatically, if your steps become noticeably shorter and wider, or if you feel compelled to stop walking completely just to perform the mental task. Experiencing a slight pause the very first time you try this is entirely normal. However, if you consistently struggle to maintain movement while speaking, it offers a helpful window into how your brain manages shared cognitive tasks. Fourth, look at the complete picture by pairing gait observations with cognitive tracking. A slowing walk or balance change is only one part of the equation. It becomes far more meaningful when evaluated alongside minor cognitive shifts. Take time to review established early warning signs of cognitive changes, such as frequently misplacing items without the ability to retrace your steps, experiencing new difficulties with familiar routine tasks, confusing dates or time frames, or pulling back from social activities you usually enjoy. If you notice that your walking pattern has changed over the past several months, and you also recognize one or two subtle cognitive changes, bring these observations together to your doctor. Presenting both details together provides your healthcare provider with a much clearer, actionable picture, allowing them to conduct a comprehensive assessment. Fifth, remember that many non-cognitive, highly treatable factors can affect how you walk. This is a very encouraging and important point to keep in mind. A change in gait does not automatically mean a primary brain condition is present. A wide variety of common, reversible issues can alter your walk and balance. For instance, certain medications, including sleep aids, sedatives, muscle relaxants, and specific blood pressure treatments, can quietly impair balance, coordination, and reaction times. Correcting a medication interaction can often dramatically improve balance. Other potential contributors include vitamin B12 deficiencies, thyroid imbalances, inner ear disturbances, subtle vision changes, joint inflammation, or mild nerve changes in the feet. This is precisely why you should never try to self-diagnose at your kitchen table. Your role is simply to be a thoughtful, detailed observer of your own body, to document changes with dates, and to share those insights with your healthcare provider so they can investigate the root cause. Looking ahead, the field of movement analysis and brain health is advancing rapidly. Researchers are increasingly using high-precision motion sensors and artificial intelligence to analyze subtle movement patterns that the human eye cannot detect. In clinical studies, wearable sensors placed on a person's body during a short walk can now identify early microchanges in movement, such as slight reductions in arm swing or subtle alterations in step timing, years before traditional symptoms become obvious. While smartphone step apps and basic smartwatches are not diagnostic medical tools, many of them do quietly track metrics like walking speed, step length, and double support time over months and years. Paying attention to long-term trends in your own device data can offer a helpful secondary baseline to discuss during your routine medical checkups. Ultimately, one of the most effective tools for monitoring your overall neural and physical health past the age of 60 is simply paying close attention to your daily movement. The scientific literature consistently underscores a powerful message. Changes in gait, speed, rhythm, and dual-task ability often appear long before memory concerns become obvious on traditional paper tests. By understanding these early physical signals, establishing your personal speed baseline, observing your tandem step, paying attention to how you move while talking, and sharing accurate, dated observations with your physician, you empower yourself to catch health changes early when interventions, physical therapy, lifestyle adjustments, and medical treatments are most effective. Take time this week to note your baseline, observe your walk safely, and stay proactive about your mobility and brain health. If you found this video helpful and educational, please hit the like button and subscribe to the channel. Sharing this information with friends, family members, or walking partners over 60 can help ensure we all stay proactive, steady, and sharp. Thank you for watching, and I look forward to seeing you in the next video.